It was American author Joyce Menard who said, "A good home must be made, not bought." In this lesson, we're going to compute the perimeter and the area of a polygon. We're going to compute areas of irregular regions, and we're going to compute volumes of regular solids, all to answer the question, how much space do I want? How much space do I need? Before we get into it, let's make sure we're ready for this lesson by taking a look at warm-up number 2. A circle has a diameter of 10 feet. It is cut into 2 semicircles. Find the area of one of the semicircles to the nearest hundredth. So we have to understand we have a circle with a diameter of 10 feet, which means we have a circle with a radius of 5 feet. We know that the area of a circle is equal to pi r squared, but we only want to know what half of this is. So this means we're looking for the area being 1/2 pi 5 squared. We can round pi as being 3.14 for the purpose of this, giving us 1/2 times 3.14 times 5 squared. This will give us right about approximately 39.25. Now, the more accurate you use as the pi, the more this number could change slightly. Now, let's take a look at a problem that you will be able to do by the end of this lesson. Mike's bedroom measures 16 by 14 and has a 9-foot ceiling. It is well insulated on the west side of the house. What size air conditioner should he purchase? Air conditioners are sold according to their BTU, British Thermal Unit rating. An air conditioner must have the appropriate BTU rating to cool and dehumidify a room of a certain size. If the rating is too low, the room may not cool sufficiently. If the rating is too high, it may shut off before removing the humidity. Many appliances salesperson use the formula known as while dividing by 60 to compute the correct BTU rating. In this formula, W represents the width of the room, H represents the height, and L represents the length. The level of insulation is represented by I. If the room is well insulated, I is equal to 10. And if the room is poorly insulated, I is equal to 18. A variable E represents the exposure, the direction the main outside wall of the room is facing. If it faces north, E is 16. If it faces east, E is 17. South, E is 18, and west, E is 20. So let's look at this BTU rating, which is while divided by 60. And in this case, we know that we get 14 by 9. The insulation rating, which is 10 because they said it was really good. It has a length of 16, and it is facing west. Divide all of this by 60. And just by using a calculator, we can find 6720. So Mike should round up to the nearest thousands and purchase an air conditioner with a 7,000 BTU. When you begin to look for a place to live, price and location are not the only factors you should consider. One important consideration is the number of rooms, room size, and the layout of the living space. This information is shown in a floor plan. A floor plan is a drawing of the layout and the dimensions of the rooms. The floor plan shown is a 1-bedroom apartment. There is some of the information that the floor plan shows you. The apartment has a kitchen, a dining room, a living room, a bedroom, and a bathroom. The bathroom has a sink, toilet, bathtub, and 1 window. The bedroom is 15 by 12 feet. It has 2 windows and 1 doorway. The living room is 20 by 12 feet. It has 1 large window and 3 entrances, one being the outside entrance. The dining area is 8 by 7 feet and has 3 entrances and no windows. The kitchen has cabinets, counter space, and a sink, stove, refrigerator, 1 window, and 1 entrance. Estimating a floor plan allows you to make intelligent decisions before you move in. It helps you determine what furniture you will need to fit in each room. Everybody likes to have ample space that suits their living style, family size, and hobbies. Larger spaces are usually more expensive, so deciding what you want and what you need is a balancing act with what you can afford. You can create floor plans by hand or by using computer software specifically designed to draw floor plans. Floor plans are drawn to scale. They are drawn in the same proportion as the actual home. Even if you never need to draw your own floor plans, you need to know how to read them. Here, we're going to learn how to read floor plans and use the information in floor plans to make buying decisions. Jerry is using the floor plans for his new home to help him purchase base molding for the place where the walls meet the floors. The plans are drawn using a scale in which 1/4 inch represents 1 foot. He measures the walls on the floor plan with a ruler and finds a total of 23.5 inches. If the molding costs $2.10 per foot, how much will Jerry spend on molding? Jerry needs to use proportions to convert the scale measurements to the actual measurements in feet. Let's recall that the proportion is created when two ratios are set equal to each other. So if we have 1/4 inch for every foot, this is the number of inches in the floor plan, and this represents the actual number of feet in the room. We know that the floor plan gives 23.5 inches, but we don't know how many feet that is. If we solve for x, then we would find that x is 94. So Jerry needs 94 feet of molding. Since he needs 94 feet of molding and it costs $2.10 for every foot of molding, we know that he's going to spend $197.40 on molding. Let's check our understanding of this. The length of a room is 17 feet. When using a 1/4 inch to 1 foot scale, what is the length of the room on the floor plan? So we're going to set up a proportion that has inches over feet, and we know our conversion is 1/4 of an inch is going to give us 1 foot. But if we know that the actual room is 17 feet and we do not know how many inches it is, if we multiply both sides by 17, we find that x is equal to 4¼ inches. Gabriela plans to carpet her living room except for the quarter circle shown in the corner. That area will be wood floor where she'll put the patio. The radius of the quarter circle is 8 feet. The carpeting costs $9.55 per square foot. What is the cost of the carpeting that she's going to use in the living room? To find the area of the entire rectangle and then subtract the area of the quarter circle to find the area of the carpeted section of the room. In this formula, the area is equal to the length times the width, which in this case would be 25 times 16, which is 400. So the area of the room is 400 square feet. Now the area of the circle with radius r is given by the formula area is equal to pi r squared. But we only need 1/4 of this, so we're going to say the area is equal to 1/4 pi r squared, since this is only a quarter circle that's here. If we use 3.14 as pi, and we know the radius is 8, then by calculating, we get 50.24. The area of the quarter circle is approximately 50¼ square feet. We're going to subtract that 50¼ square feet from the 400. This is going to give us 349.76 square feet of carpeting. So Gabriela needs approximately 350 square feet of carpeting. We're going to multiply the number of square feet she needs by the cost of the carpeting, which in this case is $9.55. She's going to spend $3,342.50. That's going to be the approximate cost. Due to the shape of the carpet area, Gabriela may have to purchase a few extra feet of carpeting to make sure the installers have enough. This is determined at the time of purchase. Let's check our understanding of this. Let's express the area of the shaded region of the room shown algebraically. Well, the area of the large would be equal to its length times width, which would be 2x times x plus 3. To simplify this, we get 2x squared plus 6x. Now the area of the small would be equal to 5 times x. There's no need to simplify this, so it's still 5x. If we subtract the unshaded area from the shaded area, then we get 2x squared plus x. Let's compute the perimeter and the area for a polygon. D'Angelo's landscaping design is building a large gazebo for a backyard. It is in the shape of a regular octagon as shown in the diagram. Each side of the gazebo is 10 feet. They need to purchase wood for the flooring. It costs $14 per square foot for this special wood the homeowner wants. Find the cost of the gazebo's flooring. All 8 sides of the regular octagon are congruent, so they have the same length. To find the area of a regular octagon, you need the apothem and its perimeter. The apothem, as shown in this diagram, is the line segment drawn from the center of a regular polygon to its perimeter side. It's going to be perpendicular to this side. You find the area of a regular octagon with this following formula. The area is equal to 1/2 the apothem times the perimeter. Where A is the area of the regular polygon, the small a is the apothem, and P is the perimeter. The perimeter is the product of the number of sides and the length of the sides. So this perimeter is going to be equal to 8 times 10, or 80. The apothem is 12 feet long. So the area that we get for this whole thing is 1/2 times 12 times 80. This means we have an area of 480 square feet. If we multiply this by the cost of that special wood, which is $14 per square foot, we get $6,720, not accounting for waste. Let's check our understanding. A regular pentagon, 5 sides, has an area of 440 square units, and each side measures X units. Express the apothem of the pentagon algebraically in terms of X. Well, we know that the area is equal to 1/2 the apothem times the perimeter. We know that it has an area of 440 square feet. We do not know the apothem, and we know that the perimeter is 5 times X. So if we divide 440 by 5 and then multiply it by 2, we're going to get 176 is equal to AX. Now, dividing the 176 by X, we get 176 over X is going to be our apothem. Now, let's compute the area of an irregular polygon. Don digs out a region for a flower garden. He takes a photo of the garden and traces it digitally. The irregular garden region would fit inside a rectangle that is 15 yards by 20 yards. He superimposes a 15 by 20 grid over the region on his computer as shown. The area of the garden impacts the cost of the mulch, plants, fertilizer, and so on. What is the area of the garden? The garden is not a polygon, it is a free-form plane figure. This is a two-dimensional region defined by the curves and/or line segments, but free-form plane figures do not have to adhere to any other geometric requirements. Don can use probability to find the area. First, he frames the irregular region with a 15 by 20 rectangular, which is shown. The area is 300 square units. Then he generates 1,000 random points, x's and y's, with a domain 0 is less than or equal to x, less than or equal to 20, and a range 0 is less than or equal to y, less than or equal to 15. Most graphing calculators have a random number feature that can generate x and y values for this problem. Don plots the points and determines the number of points that land inside the garden region. He finds 631 points inside the garden region. He uses the following proportion: the number of points inside the region over the total number of points. This is going to be equal to the area of the region over the area of the rectangle. In this case, we have 631 over 1,000. This is going to be equal to x over 300. Solving for x, we're going to get 189.3 is equal to x. The area of the free-form garden is approximately 189 square feet. The method used in this example is the Monte Carlo method. It is based on probability. The theory is that the ratio of points that land inside the region to the points should equal the ratio of the area of the irregular region to the area of the rectangle. The more points you use, the more accurate your approximation. Let's check our understanding of this. A free-form plane figure is framed in a 20 by 20 grid that represents 20 feet by 20 foot square. To find the area, 2,000 random points are generated. 910 of them land inside the irregular region. What is the total area of the irregular region to the nearest integer? This means that we're looking at 910 over 2,000. This is the number of points inside over the total number of points. Now, this is going to be finding x over the total area that we're looking at, which is 400. Solving for x, we find that x is 182 square feet. Now let's compute the volume of a rectangular solid. Find the volume of a room 14 by 16 by 8 foot. The formula for volume of a rectangle solid with length L, width W, and height H is the volume is equal to the length times width times height, which means in this case 16 times 14 times 18, or that the volume is 1792 cubic feet. Let's check our understanding of this. A square room with sides x units long have a volume of 1900 cubic units. Express the height of the ceiling algebraically in terms of x. We already know that the volume is length times width times height, and if we're trying to solve this for h, then the volume divided by the length and width will give us the height. We know that the length and width are both values of x. X times x will give us x squared in the denominator, and we've been given the volume to be 1900, so h is equal to 1900 divided by x squared. Mike's bedroom measures 16 by 14 and has a 9-foot ceiling. It is well insulated on the west side of the house. What size air conditioner should he purchase? Air conditioners are sold according to their BTU, British Thermal Unit rating. An air conditioner must have the appropriate BTU rating to cool and dehumidify a room of a certain size. If the rating is too low, the room may not cool sufficiently. If the rating is too high, it may shut off before removing the humidity. Many appliances salesperson use the formula known as while dividing by 60 to compute the correct BTU rating. In this formula, W represents the width of the room, H represents the height, and L represents the length. The level of insulation is represented by I. If the room is well insulated, I is equal to 10. And if the room is poorly insulated, I is equal to 18. A variable E represents the exposure, the direction the main outside wall of the room is facing. If it faces north, E is 16. If it faces east, E is 17. South, E is 18, and west, E is 20. So let's look at this BTU rating, which is while divided by 60. And in this case, we know that we get 14 by 9. The insulation rating, which is 10 because they said it was really good. It has a length of 16, and it is facing west. Divide all of this by 60. And just by using a calculator, we can find 6720. So Mike should round up to the nearest thousands and purchase an air conditioner with a 7,000 BTU. Let's check our understanding. In example 6, let's find the recommended BTUs if Mike's room was poorly insulated and other variables remained the same. This means we would be looking at the BTU is equal to while divided by 60. The dimensions of the room remain the same, so we still have 14, 9, but instead of being a well-insulated room where we would multiply by 10, this is a poor insulated room where we would multiply by 18. The length of the room is still 16, and the room hasn't changed sides of the house, so we still have 20. All of this divided by 60. This means we're looking at 12,096. Remember, you want to round this up to the nearest thousand, so it's quite a ways to go, but we want a 13,000 BTU unit, all for having poor insulation where a lot of the cooling factors would be lost.